All right, we're going to do things a little bit out of order. So I want you to skip to your last example, and you'll realize there was a typo because you see this equation as your second example, and then you see the same one. So go ahead and cross off that third equation and write in this one, and that's actually where we're going to start. Okay, so go ahead and take a minute, write this into your notes, cross off that third equation, and instead write y equals 4 tangent of x minus pi over 4. All right, so when we talk about tangent, we do not have an amplitude, but we do have an a value or a stretch. So our stretch here is going to be 4. Our period is going to be, remember, it's pi over our b value. Well, our b value is just 1. So the period is pi. Then we are going to see our horizontal shift is going to be to the right pi over 4. Vertical shift, none. Our intervals are going to be pi divided by 4, and we have no flip. So if we think about this, our tangent graph, remember we're going to have 2 vertical asymptotes. That point that was at the origin, -1, +1, and connect with that tangent graph. So to start, I am going to say I have no vertical shift, so this baseline is just right at 0. I need to then count my vertical stretch. Remember, this is not an amplitude. This is a vertical stretch because I don't have half the distance of the range because half of infinity is still infinity. I don't have a y-axis here, and that's because I wasn't really sure where this horizontal shift was going to end up. So I'm just going to put it here because I think we'll be okay space-wise. Remember, you can kind of decide where you draw that type of stuff in. So my vertical stretch, instead of going up 1 and down 1, I'm now going to go up 4 and down 4. So 4, -4. My horizontal shift then is to the right pi over 4. So I'm going to decide this looks like pi over 4 to me. And remember that horizontal shift was where that origin point has moved to. Okay, so then from there I need to count out my intervals. Well, this is 1 pi over 4, so this would be 2 pi over 4. This would be 3 pi over 4. And I'm going to count 2 this way, and I will encounter a vertical asymptote. And I'm going to count 2 this way, so negative pi over 4 puts me at 0. That actually is a tick mark. And then back here, negative pi over 4, so 2 this way, and I would have hit, oops, that's not the right pen. I would have hit a vertical asymptote. Now this says just to graph one period. So I've set up a period happens between those vertical asymptotes. From my starting point, I usually go over 1 tick mark and up to my key point of 1. But now I'm going to go over 1 tick mark interval and up to my key point of 4 because of the vertical stretch. Usually I would go backwards and then down to 1 because the tangent of negative pi over 4 was -1. Now I'm going to go backwards and go down to -4 because of that vertical stretch of A. And connect my tangent. Now I could keep going, right? We know this thing is periodic. It's going to repeat. So I was at 3 pi over 4. This would be 4 pi over 4 and 5 pi over 4 and 6 pi over 4 and 7 pi over 4, where I again would hit a vertical asymptote. This would be the crossing point. This one would go to the low stretch. This one would go to the higher stretch and then continue to the infinities. All right, let's jump back to that first one. So again, I've got a tangent graph. Great. Our A value, our vertical stretch, is going to be 2. Our period is going to be pi over b, which is really just pi. Our horizontal shift looks like we're going to the left pi. Our vertical shift is 0. Our intervals will be pi over 4. And I have no flip. Okay, so again, I don't have a y-axis here. And the reason I didn't do that is because I needed to first figure out where is my horizontal shift going to be. Well, I'm going to shift to the left pi, which means I'm going to go even a little bit further left than that because I know that that shift is moving that origin point, and I know I need to go backwards 2 intervals to get to my starting asymptote. Basically what I'm saying is I need to see a lot to the left. So I'm going to draw my y-axis this time over here, just so that I have a little bit more space. So start with that baseline. Vertical shift was 0. My vertical stretch this time, instead of going up 1 and down 1, I'm going to go up 2 and down to -2. And now this is where things get a little more difficult, but we can handle them. So my horizontal shift is to the left pi. Well, left pi, I'm going to leave myself a decent amount of room, and I'm going to say is here, -pi. And again, that moved my origin point. For a tangent graph, I want to count my intervals, 2 to the right to get to the vertical asymptote, and 2 to the left to get to my vertical asymptote. So if I was at -pi and I add pi over 4 from my interval, I'm now at -3 pi over 4. And if you need to do a little fraction work, that's okay. -pi plus pi over 4, this would have been 4 pi over 4. So now I'm at -3 pi over 4. Then I need to go one more, and I'd be at -2 pi over 4, which is really -pi over 2. And when I get to that value, I now have the vertical asymptote. Going backwards then, if I was at -pi and I need to go backwards pi over 4, now I'm at -4 pi over 4 minus pi over 4 is, okay, -5 pi over 4. That makes sense. And then I'm going to go backwards one more, which would be -6 pi over 4, which would be -3 pi over 2. That got a little messy. And that's where I'm going to hit that vertical asymptote. So I had to graph one period, so I'm going to go backwards 1 and down to that vertical stretch, up that vertical stretch, connect through as a tangent graph. Now again, I could graph more than this. I could go -pi over 4, 0, pi over 4, pi over 2. I would have hit vertical asymptote, and then my stretches again. Okay, and there's our tangent graph. All right, last one, graph one period of this thing. So I have a tangent function again. I'm going to start by factoring out this 3, just so I can read things a little bit easier. Okay, so my vertical stretch, again, not an amplitude, vertical stretch is 2. The period is going to be pi over b, which is pi over 3. My horizontal shift is going to be to the right pi over 3. Vertical shift is 0. I don't know why I chose to write 0 there. My interval is going to be pi over 3, the period, divided by 4, which is really pi over 12. So we've got some tiny fractions to count by today. And this negative sign means that, yes, there is a flip. So instead of having our setup of asymptote, asymptote, increasing tangent function, I now am going to have a decreasing tangent function. Okay, first thing to start with, that vertical shift of 0. This one, my horizontal shift is to the right, so I'm going to choose to put my y-axis over here because I need some more space to the right to draw my graph. My stretch is 2 and -2. And my horizontal shift was at pi over 3. So I'm going to choose that this is pi over 3. Remember, science class, we get a little bit of arbitrary choosing. We're going to let you space how you want to. All right, so I'm at pi over 3. And I now need to count an interval of pi over 12. Common denominator would say this is 4 pi over 12. Plus pi over 12 is going to be 5 pi over 12. So then I should get 6 pi over 12, which is really just pi over 2, and I've hit a vertical asymptote. Then if I was at pi over 3, and I needed to go backwards pi over 12, this again would have been 4 pi over 12. 4 minus 1 is going to be 3 pi over 12, which is really pi over 4. And then I need to go backwards one more pi over 12. So this was 5, this was 4, this was 3. This would be 2 pi over 12, which is really pi over 6. And now you might be thinking, these numbers are ridiculous. How are we simplifying all of these? If you need to count by the actual pi over 12s as you go, that's totally fine. And then just simplify your fractions when you get there. So then usually I go over one tick mark and up to the vertical stretch. But because of this flip, I'm going to go over one and down that vertical stretch. Backwards one, up that vertical stretch. And I have my reflected tangent graph. Now, could we keep counting and do another period going backwards? Sure. So here I was at pi over 6. That was 2 pi over 12. So this would be 1 pi over 12. And this would be 0 pi over 12. And then I'd be at negative pi over 12 and negative pi over 6, where I would encounter another vertical asymptote. This would have been an origin point. This would have been the high stretch and the lower stretch. Almost at amplitude. Goodness gracious. And there we go. Okay, so again, important things to think about with tangent. Finding all this stuff, okay, is still important. Except instead of an amplitude, we have a vertical stretch. The period starts with pi, because that's a regular parent standard function, divided by b. And then when you count your intervals, start at your horizontal shift, count 2 to the right, asymptote, 2 to the left, asymptote. Now, in the last video, I mentioned that you could find what we call our starting asymptote by saying negative pi over 2 is equal to our bx minus c. Well, bx minus c was 3 times x minus pi over 3. So my starting asymptote, I'm going to divide everything by 3. So this is negative pi over 6 equals x minus pi over 3. I'm going to add pi over 3 here. Negative 1/6 plus 2/6 is pi over 6, and that should be my starting asymptote. Well, if I look up here, what was my asymptote? My graph won't scroll right now, but my starting asymptote was at pi over 6. That was the asymptote, if I had my blue dot, which this is not showing, was 2 tick marks to the left of that horizontal shift. So you don't have to find the starting asymptote. You'll find it if you plot your horizontal shift and count 2 intervals to the left. Again, starting asymptote, plot your horizontal shift, and go 2 intervals to the left. And that's graphing tangent. We'll do lots of practice in class. This one's important because there's a lot of little differences that might trip you up from sine and cosine.